Hello folks, this is a video on how to calculate the uncertainty of a slope using the error bars plotted. Here I have a sample data set for distance versus time of a student walking down the hallway, which you've collected. And we're going to work on this data set here to first give us the slope, which is going to be the velocity of the student from this graph, and then we'll use the error bars plotted to get the uncertainty of that slope. This is all a process that the IB requires of you, so we're going to teach it this way, and this is how we're going to use it in this class moving forward. Okay, so first thing to do is just a quick note here. We can very easily find the slope of any function by taking 2 points, and then we can find the slope by finding the rise over the run. So first we have a point here down at the bottom at 0, 0, and then we have a point up here at, I'm going to call this 6, 12. So 6, 12. Okay. And then to find the slope here, we can say, okay, well, the slope is just rise over run. So I have rise over run. So the change in y over the change in x is going to be the final minus initial in y over the final minus initial in x. So x final minus x initial. Okay. So I take those points. I have the point 0, 0 down here at the bottom. Like I said, that's my initial point. And so I get, for my final y value, I have 12. Minus 0, which was my initial y value, and then for my final x value, I have 6 minus my initial x value, which was 0. So this gives me a slope of 12 over 6, or of course 2. So this is a slope of 2 meters per second. I'm going to put 2 decimal places on that, just to work with, okay? Don't mind too much about the significant figures here. Okay, so there's my slope. Great, we found the velocity of the student. Now we need to report what that uncertainty is. I'm actually going to clear a little bit of space up here at the top so you can see my work that I did. I'm going to do this again, but for a couple of different lines. All right, so I just need some space up here. So I'm going to clear this out. All right, and then I'm going to really quickly draw a nice slope line as straight as I possibly can. This is, of course, some manufactured data, so the slope is going to be nice and straight here. Very probably the data that you're working with is not going to be perfectly straight like this. Okay, so how do we work out what the uncertainty of the slope is? Well, first we identify the maximum possible slope and the minimum possible slope. What do I mean by this? Well, if you look at the data points, each one of these data points has sort of like a width represented by, you can see my cursor down here at the bottom point. It's got a width represented by the uncertainty in time and a height represented by the uncertainty in distance. Okay, so the point is sort of, each one of these points is not perfectly infinitesimally small. They each have their own width and height. So we're going to use this to plot the possible width and height of each of these the beginning point and the end point, and that's going to give us a range of separate slopes. So the goal here is to find the max slope and the minimum slope. Okay, so let's lay out what I mean by this. Okay, I realized I wasn't in full screen mode there for the beginning, so let's lay out this problem. For this example problem, the uncertainty of time is given as plus minus 0.80 seconds, and the uncertainty of distance I'll go over here a little bit. Uncertainty of distance is 0 plus or minus 0.20 meters. Let me write that time out a little bit nicer. So time is plus minus 0.80 seconds, and the uncertainty of distance is plus minus 0.20 meters. Okay, which gives us the uncertainty bars that you see plotted here. What does that mean? Well, it means that we've got basically a couple of different points that are of some interest to us. So let's take, for example, let's start with the minimum possible slope. The minimum possible slope would have a beginning point at this point right here. So it would be high and far to the left on the bottom point of the graph, and then it would be low and far to the right on the top point of the graph. So I'm going to erase this 6, 12, and I'm going to put it right here. So this is the minimum slope line. You'll see if I'm really careful, and maybe I'll grab a drawing tool here. If you're doing this on paper, I would advise using a ruler here. If you're really careful, and I'm using a ruler against my screen. Oh boy, hang on. Don't break anything. All right, good, careful. I can draw a nice straight line, roughly straight. There we go. And fill out that middle section there. There we go. That blue line represents the minimum possible slope that we could have for this function. And I can do the same thing for green. For green, I'm going to erase down here. The maximum possible slope would be a line connected by this uncertainty. So for the bottom point, bottom as low as possible and then to the right, and then for the top point as high as possible to the left, which give us our maximum possible slope for this data set. So I'm kind of just visually following the uncertainties given by the error bars and using that to construct a set of lines which show the minimum and maximum possible slopes. So how do we actually show, now that we've got this visually, how do we actually calculate the minimum and maximum, the uncertainty of the slope? How do we actually calculate it? Well, let's do it. So first, we'll have to figure out what these points are. And once we do, my tablet's disagreeing with me. Once we figure out what these points are, we can find the slopes of the green line and the slope of the blue line. And then if we find the range divided by 2 here, we will have the uncertainty in the slope. Okay, so for time point 1, and this is going to be the minimum, so time point 1, this is going to be the 0 point, so that beginning, minus the uncertainty in time, right? So minus 0.8 gives us a coordinate value of negative 0.8. And then distance for point 1 gives us is 0, the original coordinate, plus the uncertainty of distance, which was 0.2. So a 0.2 in the y-coordinate. So if we go over here, we can record that here. The coordinates for this point over here are negative 0.8, comma 0.2. And now we can do this guy up here. All right. Time point 2. I'm very carefully showing all my work here. The coordinate here for time is 6 seconds, so I've got 6, and I'm going to subtract away, add my time uncertainty, 0.8. Gives me a value of 6.8 for my x-coordinate. Distance, 0.2. This is going to be 12 is my distance value, minus my uncertainty 0.2 to give me 11.8. So now I have my coordinates for this point here. So I have 6.8, comma 11.8. Excuse me, I think I made a mistake. No mistake. Good. Yes, good. Okay, so I've got my 2 points here. Now I can find the minimum slope. The minimum slope is the change in y, the change in x. So I have that the change in y is 11.8 minus 0.2. Change in x is 6.8 minus a negative 0.8. So I have that this is 11.6 divided by 7.6. which gives me a minimum slope value of 1.53 meters per second. This is the lowest that my velocity could possibly be. All right, and now we're going to carry through that operation one more time for the maximum slope. Okay, but it's going to be the same process over again. So I'll let you follow that process to double check my work here. All right, but suffice it to say, the maximum slope we have here, just to keep this video short, the maximum slope that we have here is 2.82 meters per second. Okay, you can trust me or you can check my work. I recommend checking my work because I don't always get it right. All right, but the key here is, how do we get the uncertainty from these two values? How do we get the uncertainty in the velocity? Well, it's just the range divided by 2. The range of slopes divided by 2. In other words, it's going to be 2.82 minus 1.53 divided by 2, which gives me a value of 0.645 meters per second. There's a preliminary value for the uncertainty. So remember, when we report our value, we've got to make the precision match. So I told you I've got a value of 2 meters per second plus or minus the uncertainty, which is 0.645. But look, I don't have, I'm only precise out to the hundredths place, so I'm going to cut off and round up that last value and report my uncertainty as 0.65 meters per second. And there's your answer. Okay, this is the process we're going to follow to find the uncertainty of the slope for every single time in this class. I've got some resources on Canvas that walk you through making a graph like this in Desmos or in Logger Pro, which is the graphing software used to make this picture here. But otherwise, go ahead and take a look at that and practice by finding the uncertainty of the slope in your walking down the hall lab. Thanks.